Hi, everybody. This is Module 1, Lesson Chapter 8, Algebraic Reasoning, Graphing, Connections with Geometry. So I'm going to get my PowerPoint started, and we're going to go ahead and get going. All right. So for question number 1, we were asked to draw a graph for each of the following scenarios and explain why the graph corresponds to the scenario. So for graph A, we were asked to show and explain the graph to correlate with the function of the amount of gas in a tank when a driver refills and he's driving across country. So what you'll see first is I have actually put a star on each of these, and that's just kind of your beginning point. And this little, I tried to make it as red as possible, that's a stop sign. So that's where it ends on each graph. So for the gas in the tank, you can see that as the driver starts driving, the line's going to go down. That's because you're losing gas as you're driving a distance. So obviously he's going to have to stop for gas, and that's what this point represents, because he's going and he's getting gas, but he's not going anywhere. So that line's going pretty much straight up. So then as the trip continues, he eventually gets to his destination, but he also loses all of his gas. So right here we have this line represents the gas in the tank, because you can see it going up and down there, and this is the distance traveled because he's just going further. So for part B, we are to show a graph that shows an elevator stopping on the floor. So this right here represents the height of the elevator stop, and this is the stop at each floor. So as you can see, it kind of looks like stairs. You're going up a floor, stopping, going up a floor, stopping, and so on and so forth until you finally reach that top point. And then for C, we were to represent the height of a ball bouncing during the time period that it goes. So you see that the ball is going to start off pretty high because it's got all that momentum going into it. And then it's just going to slowly start to get lower and lower until the ball finally loses all of that momentum. So that's what that represents. And then we're to show a graph to correlate with the function of the length of a shadow of a flagpole during the day from beginning to end. So you'll see that the shadow is going to start pretty low and then rise up as the sun rises. So the shadow is going to be longer at the beginning and end of the day than it is during the day. Okay, so moving on to question number 2. Now you're probably looking at that and wondering what is going on. Well, let's explain. So for question number 2, we are to look at function machines. So we are given a function with this. So we have f of x equals 3x, and then we are also to find the g of f of x equals fx plus 8. And the greatest thing I could have done is done this in Excel. Excel used to terrify me, but after using it for this program, for Math for Teachers, it's actually helped me become more comfortable with Excel. So don't let something new scare you, because in the end, it's totally worth it to use. So what we were given was, we were given 0, 1, 2, and 3 as our x, and they wanted us to input that into the f of x equals 3x, as well as the g of f of x equals f of x plus 8. So what I've done here is I've listed in Excel, underneath my x column, all of the x possibilities we had, the 0, 1, 2, and 3. So then the cool thing about Excel is that it's going to do that for you. So it's going to put your 0 in the x spot, your 1, your 2, and your 3, and give you your answer. So we know that 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, and 3 times 3 is 9. So then we're going to go over here, and it's essentially just adding 8 to what we already know. So we have 8, 11, 14, and 17. Now to the right, you're going to see my graph that I have chosen to use. So we have our peach line represents x, our light orange line represents the f of x equals 3x, and right here we have the burnt orange line that is the g of f of x equals f of x plus 8. So that's what we have for number 2. And like I said, Excel made this super easy for me to understand. It was putting, words to a picture, and it was fabulous to use. All right, so for number 3, we are to show and explain the slopes of the line segments determined by the given pairs of points. In each case, tell whether the segment is vertical, horizontal, slopes upwards to the right, or slopes downwards to the right. So we were given parts A through C. So what I've done up here is this is obviously part A. Now I have solved this two different ways. To find the slope, you can either do that algebraically with a problem, which I'm going to show you after this, or you can use rise over run. So let's get into that a little bit more. So what I have done here is we just have A gave us points P and Q, which is 3, 1 and 5, 5. So what I've gone over here and done in Excel is listed my columns of X and my columns of Y. Now X starts, Y finishes. So kind of like the alphabet we've got going on. So we have the point 3, 1, and then I put a 4 here because then we have the point 5, 5 given to us. While we don't know what that point would be for 4, it's just kind of keeping you visualizing that it's all counting numbers. So now we're tasked with finding the slope. So I've taken this and then I've charted it as a line. So we have our point 3, 1, and then we have our point 5, 5 up here. So the cool thing is that to find the slope, we were able to take a right triangle, which is this lovely orange piece right here, and you see how it perfectly rests on that line, and it kind of looks like a diagonally cut sandwich is what I like to think about. It fits perfect. It's beautiful. And you see the other half that's just kind of invisible right here. So to find the rise, that is going from this point down here all the way to the point it would take to get over here. You're not going diagonal, you're going straight up. So our rise is 1, 2, 3, and 4. So our rise is 4. And then our run, we're running to that point over there from our rise. So we have 1 and 2. So our run is 2. So by taking our rise, which is 4, putting it over our run, which is 2, we find that the slope is 2. So that was 3A. Let's go on to 3B and use some algebra for it. So I'm going to move this picture down. Okay, so for part B, we were given points R, which is 5, 8, and point S, which was 5, -8. So what I've done in Excel is I have listed in my column X over here just 5s, because we go from 5 to 8 and 5 to -8, so all that's just going to be 5s. And then I've done counting just from 8 all the way down to -8. So that's represented right here on my graph on the line. And you're asking, well, you just said use a right triangle. How can we do that here to find the slope? Well, I decided to do it algebraically. So let's find that slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. So whenever we input these numbers there, we end up with -8 minus 8 and 5 minus 5. That comes out to be -16 over 0, which means the slope is undefined for this one. So let's move on to 3C. And I've also done this algebraically again. So here we have U is -1, -4, and V is -4, -13. So we have right here in our X column, we went from -1 to -4, so I just went ahead and did counting down that line. So -1, -2, -3, and -4. So we have our -1, -4 all the way down here, and then we have, well, actually that's right there, and then we have our -4, -13 right here all the way at the bottom. So again, I just solved this algebraically with that formula I just showed you. So we end up with -13 minus -4 over -4 minus -1, and we end up with -9 over -3, which gives us a slope of 3. And that completes question number 3. So let's go into number 4 in this awesome looking graph right here, again done in Excel. I didn't know Excel was this awesome. So for number 4, we are to show and explain the graph of each of the following functions and describe the similarities, differences, and relationships between the graphs. So here what we have, I have chosen the range for X to be -10 and 10. I like the evenness of 10. It's just a personal preference, to be honest with you. You could have done -12 to 12. You could have done 9 to -9. It's just your personal preference, really. So we were given the functions for this. We were given y equals x squared, y equals x squared plus 7, and y equals x squared minus 7. So you already know there's going to be a difference, obviously, between the last two because you're adding 7 in one and you're subtracting 7 in another. So you know those lines are going to be the complete opposite of each other. Now that x squared, you don't know quite where that's going to fall on your graph, but let's figure it out. So here's what we had to do. So I've taken my range of numbers here, the negative 10 to 10. I've input all of these x's into the x's in these functions. So we have, if we place negative 10 squared, we have 100, so on and so forth down. Same thing here. The x squared plus 7, we input all those x's. The x squared minus 7, input all those x's there. So then we've taken our wonderful table chart in Excel and we've turned it into this lovely graph. So I'm going to show you, the blue line represents our x squared. So it sits right in the middle, and the main point of this parabola hits 0, 0. So it's just right there. It's neutral. It's in between these two. So you know if you take this point and you're adding 7, you're going up to our lovely orange line, which represents the x squared plus 7. Now if you go to our little neutral blue line here and you go down to the silver line, you can show that that is subtracting 7, just like our problem. Y equals x squared minus 7. So you can see that they are all forming this lovely up-down U here, this parabola, but they're all spaced out by 7 because that's what the function they gave us did. So that's number 4. Let's go on to number 5. So number 5, let's move my picture out of the way again. Okay, so for number 5, we were to show and explain the equation of the line, the given point that is perpendicular to the given line. So the slope of the perpendicular line is the negative reciprocal of the slope of the given line, and the given line is neither vertical or horizontal. Okay, so for A, we were given y equals negative 3/4 x plus 5, and the given point that they gave us was R, which is 6, negative 1. So first what I did is I kept my range, my negative 10 to 10. I really liked it. I'm going to keep using it, okay? Don't fix what's not broken, right? So then we have our y equals column. Well, they gave us that lovely y equals. It is negative 3/4 x plus 5. So what we've done here is we've put in all of our x's in there, and all of that solved for us on Excel. So let's ignore this last column real quick. So what they gave us, the point R, which was 6, 1. I've represented that with this purple little happy face right here. He's right there. He's happy. He's good. Okay, so the original line we were given, that's this blue line right here. That's the negative 3/4 x plus 5. Well, you're saying, well, what's that other line? Well, remember, the problem wanted us to solve where's the perpendicular line, okay? So we'll come back to this, but I'm going to show you how to get that. Okay, so the point we were given was 6, negative 1. The slope we were given was negative 3/4. This is the point slope formula, so that's what we're going to use to find that other line. So we need to find the reciprocal slope. The reciprocal of negative 3/4 is a positive 4/3. So that's going to give us, with this formula, 4/3 x minus 9. So let's go back up and look at our chart, and that's exactly what I've put here. Y equals 4/3 x minus 9, and that has given us that lovely orange line, which is what the question asked us to do. It told us to give the perpendicular line, okay? And we've done that with the orange line. So let's go and get to the second part of 5. Now this next part of 5, 5b, we start and we were given 2y plus 9x minus 5 equals 0, and the point of S 0, negative 3. I mean, just positive 3. So we need to go ahead and solve for y because we can't put this on a chart just yet. So as you can see, I've solved for y. We've gotten rid of our 9x on both sides, gotten rid of our 5 on both sides, and then divided by 2 and wound up with negative 9/2 x plus 5/2. So let's go to our chart, and that's exactly what I put here. We have what I just solved for, the negative 9/2 x plus the 5/2. So I've kept my negative 10 to 10. I'm staying true to that, and we're just going to keep going with it. And that has solved that. So that's our lovely blue line here. So then you found your reciprocal, which is positive 2/9, and then you've done the formula to find that we needed 2/9 x plus 3 for our perpendicular line, which is this lovely orange line running right through that. In part A, I showed you that formula, and that's just how you end up getting that. So right here, I've shown it. We took our slope, which was negative 9/2. We found that slope reciprocal. We used the formula that we were given, the y minus y1 equals m times x minus x1. We solve that all the way down to get the 2/9 x plus 3. So now let's go on to number 6. For number 6, we were to show and explain the equation of the line that is tangent to the circle of radius 9 at 0, -9 and whose center is at the origin. For B, show and explain the equation of the line that is tangent to the circle of radius 9 at 0, 9 and whose center is at the origin. And C, to compare part B and part A. So I went ahead and shown both those tangent lines. So we were tasked with finding the 0, 9 and the 0, -9. We weren't tasked with finding the -9, 0 and the 9, 0. I put those up there just so you can see. This is let me get back to it, sorry. That was a perfect circle, okay? It is. It's right there. You can see that. I'll get to the bigger screen here. There we go. All right, so our tangent line equation is y equals 0x plus 9. It's going to give you 9. Down here, it's y equals 0x minus 9. It's going to give you that -9. These lines sit right on the outer edge of that circle. That's our tangent line. You can see they both have a space, you know, in between you from 0 to 9 and 0 to -9. That's how far those are apart. Your circle, in the middle, you have what's called an origin. That's the starting point. That's where it all happens, okay? So then you can say the same for these two lines over here. We could move these red lines and turn them and put a tangent line here and a tangent line here, and it would be the same thing because this is a perfect circle. What I've done to show that is put it in a perfect square. And so you can see these grid marks, that middle point, I did that so you can see that origin. And so that's what that asked for. So we have come to the end of this video. I hope that you learned some more and that you enjoyed it. So I will see you next time.